All right, welcome everyone. I'm glad to see some familiar names in the participants list. To give some context, so I see Angela's co-host, so she'll help me monitor the chat, so you can just speak up if I miss something. So I think I know some of you guys are in our independent study course, and so some of you are looking to do R packages. But I thought I'd make this kind of a broad topic. It's the first time I've given this talk, so we'll see how it goes. Do not hesitate to just unmute and ask questions or throw them in the chat as we go through in terms of clarification. Happy to do that. But sort of my plan, we'll see how long this goes. I don't know. I'm going to start. I got a bunch of prepared slides to kind of go over the sort of basic structure of an R package and sort of the things that you'll need to do. And my hope is that these slides will serve as a bit of a reference as you go back and you're starting to develop a new package. Then we'll actually do a demo. We'll build a brand new R package based upon some code we wrote in the last meetup. So we'll do that. We'll walk through that. I have a couple of slides because I have some thoughts on ways of including Shiny apps and packages, and actually something I'm trying to expand upon. Actually, today I was spending a lot of time, and so hopefully I'll publish a new package and I'll write a document up on that framework, particularly because I do it a lot for teaching. So I'm trying to standardize that process. We'll talk about how to release it, and then I got some resources if you want to learn more, or other reference materials, and we can do other questions kind of more broad. Okay, so let's talk about R packages. I just kind of stole this slide from my intro to R package. I presume everybody kind of already at this point knows what a package is, and I'm kind of presuming you're somewhat comfortable using R, and at least at the point where you could write a function. So that this is a part of really kind of putting that in. But it's kind of interesting. I kind of pulled this dynamically. So I think I built this yesterday, but as of yesterday, we're approaching 19,000 packages. To give you a sense of how long I've been using R, I remember when there were far fewer than 1,000. It's like at one point I kind of knew what every package available was, and kind of had a sense of what it did. And now I can't even keep up. But it's growing exponentially. So, anyways, so that's just on the CRAN. That doesn't even include what people publish on GitHub. So, I probably fewer than half of the packages I've written are on that. Do I bother to put them on CRAN for a host of reasons? So anyways, yeah, so you've probably been using them, and I think packages are what makes R so interesting. Is it's such a flexible and easy way to expand the functionality of the core language to do all sorts of things. If you don't know the history of R is really based upon S. And S was developed at AT&T Bell Labs in the 70s, and it was designed to be a glue language. It was designed to work with other languages, and the goal was there were all these different research teams there who are working in all different languages, C, machine language, or whatever, binary, or COBOL, or what have you, and they couldn't share each other's libraries. And so S was designed, okay, well, just write a little thin layer on top of it, and then that'll be the common interface so we can kind of talk to each other. And so when R came in the late 90s as sort of a, syntactically, compatible to S, open source replacement to S, they kind of inherited that kind of origins, right? So it made it very flexible to expand the core functionality. All right, so if you're going to start developing packages, you might have a lot of this already done. If you follow like my instructions, a lot of this in terms of installing R, you probably do some of this, but you're going to need tools to actually build, do the compiling and building. And so there's a bunch of R packages we're going to use tonight. DevTools, Roxygen, and Use This are three packages that really have made package development substantially easier than it used to be. But on top of that, like if you're a Windows user, you're also going to need R tools, because that's going to have some compiler tools in there that these packages are going to leverage. If you're on a Mac, you're going to need to have the Xcode command line tools installed to do some of this. So I have a link here. You can download it. And then once you download it from the App Store, it's free. You can just run this command in the terminal. Once you do that, then we're not really going to interface directly with the terminal. We'll do everything from our. If you're a Linux user, I generally presume you know what you're doing. But if you're on Ubuntu, for example, what you want to do is install r-based dev, and you can do that. You make sure you install that package. So getting started, really, a package is kind of a well-defined, directory structure with certain files and certain locations and what have you. So we'll see when we go through this example, right? The use this has a bunch of like really useful functions to help you get started. So to get started here, the package we're going to create tonight is called Loess because it's a visualization around doing Loess regression. And if you've taken my course, I usually teach it. And really all we do is going to create a package with that given path. And so here I'm just going to put it in my home directory because I've been creating it over and over and blowing it away. And this is what you get. This is the result. If you just run that command, so you can see here, I just took a screenshot from my RStudio window. So we have a directory called R, which is where our functions are going to go. We have a get ignore. So there's a presumption that you're going to probably eventually use get to manage your package. But if you're not going to use get, you can just ignore this file. But it pre-populates with common exclusions that you're not going to want to include in get. Our build ignore is similar to get ignore insofar as it's a way of listing files or directories that R should ignore when it's trying to build your package. So by way of example, at some point, if we're going to put this up on GitHub, we're going to publish a website in the docs folder. Well, docs isn't really a proper folder in terms of an R package. So this just tells R, hey, just ignore the docs folder, even though it's there. It's not really part of the package, right? It's going to be kind of a part of this bigger picture stuff. So it's really just a text file that lists things to ignore. Description we'll look at in a moment. That's kind of key metadata. Then we have here, because I called it Loess, it's going to create a .rproj file. So presumption is you're going to use RStudio, and this is the project file to work with that. And then a namespace is, we'll talk about that in a few minutes. This is a file you're not going to edit directly, but this defines sort of dependencies that your package has, as well as what functions and objects in your package are exported to the end user. So because you can have private functions and public functions. And so the namespace is going to be how we handle that. So the description file, this is what the default looks like. If you just ran that command, you could see it's kind of has this, I can't remember the format of this, but it's, parameters : values, right? So, and a lot of the key ones are here. We're going to add a few here as we move forward, but this is the base. And some key things you need to look at is like the package name. There are some rules in terms of package names. They can only be alphanumeric. You can't have underscores. There's a lot of special characters aren't allowed. As I learned, underscores aren't allowed. I tried to do that today. And then a title is a one-line title case, and it matters title case. If you try to submit to CRAN and it's not title case, they will reject it. So they check these things. Version numbers, and you have things like authors and descriptions and the like. So you're going to generally just open this up and kind of fill it out as you go through, as you're starting to develop your package. So on the author thing, what's kind of interesting is you can have as many authors as you want. They can be comma separated. And so the key piece here is, particularly if you're going to be collaborating, is the role. You need to have at least one maintainer, according to CRAN rules, and that's sort of tells the end user who should they contact first if there's an issue, and in particular who CRAN should contact if there's an issue, which they will do from time to time. You'll get a notice that says, hey, your package is no longer functioning because of maybe there was an update in R, and things don't kind of work, and you have to fix it up. So I listed out here. So creator, authors, contributors, copyright holders, and funders. These are sort of kind of the basic ones you want to use. Creator and authors are probably some of the key ones. Two other fields that don't come in by default that are really useful to have that you should add is a URL. And typically I just set the URL to my GitHub repo for the package. And then bug reports, you just kind of add issues, and that directs the user. So if they find an issue with your package, where should they report it? If you don't do it, they're going to send you an email, although people will just send you emails anyways. But using the GitHub bug tracker is really a nice place to kind of keep track of what's going on. If you're going to publish to CRAN, if you're thinking of going that path, you will have to have a license. Although I highly recommend deciding, a license up front, even if you just put it on GitHub. And it could be proprietary if that's what you want to do. Say so. Otherwise, it leaves a lot of people questioning, what should I do to use your package? I do a lot with GPL. That's sort of my kind of go-to license. So that means if anybody makes a modification to it, they have to contribute the modifications back or also make them public, which I kind of like, kind of promoting open source software. Although MIT is also a very popular one. That's a very kind of liberal, people have a lot of latitude in how they can use your package. If you're unsure, I provide a link. This is one of many websites that you can use, can ask you some questions and kind of decide what license you want. But really the key is picking one. These are the common ones. So the use this package have a whole bunch of functions. And so if you want to use GPL, you can just call the use GPL license and it will take care of everything for you. It'll add the right, it'll put the license file in your directory. It'll add the correct attribute to your description file. And that's really all you need to do. So it's pretty simple to do. The harder part will deciding which one to use. All right. So very likely your package is going to depend or leverage other packages. And so this becomes a really important piece and sometimes where I often get hangups when I'm trying to get the package to pass some tests. I'll start here. So prior to R214, really the only way you could do it is with this depends. That's now been kind of deprecated and generally not used. So in 214, R added much better environment management across packages. So really now what the two you're going to use is either imports or suggests. And what's nice about these is with imports, it's going to import that package just for your package's environment. So it can be utilized within. And so it kind of helps avoid sort of name conflicts across packages. So generally you're going to do import. Suggest is used in cases where it's just going to enhance your package, but it's not really required to use. So situations where I'll make something suggest versus imports is it's a package I'm only using in a vignette, right? It's not core functionality to the functions I'm writing in my package, but in order for the vignette to build, I need to have it. Like a common one is GT, right? For creating tables. If I want to create fancy tables in the vignette, I'll put GT as a suggests instead of an import. If I have shiny apps in my package that aren't really core functionality, they're just sort of there to enhance or to demonstrate, I might put it in suggests as well. But you could put everything in imports and probably be fine. So all of this is kind of managed in the namespace. And you don't really need to edit that directly. So you can just use the use package in the use this, use package function in the use this package. And you just give it the package name and what type it is. So if you do imports, it'll kind of handle all that for you. And then there's another kind of useful function called use tidy description. So you made a bunch of changes to your description. This will just clean up the file. So the formatting is kind of nice. And if you need more details, I have a link here to Hadley Wickham's book on the page on these descriptions.
Jason, there is a question about license from Sean.
So that's a good question. So you probably would license. So Creative Commons could apply to vignettes. And so packages are really kind of thought of as a collection of code. Although it's really code, data, and documentation. So some of the licenses kind of apply there, but there's no, I don't think there's any, oh, there is a Creative Commons. Yeah, you could use that one. So But I tend to avoid Creative Commons for code. I'll try to use a proper license and then use Creative Commons on sort of the vignettes.
Yeah, that makes sense. Thanks.
Yeah. Bikram's asking, what's the syntax to import multiple packages? So what you're going to do is you're going to do this one at a time. And it's sort of you do it once and then you're good to go. There is going to be a second part where you're going to determine specifically what you want to import. All this is doing is modifying the description file. And R is going to use the description file. When you install a package, you probably have noticed this. You install something. Yeah, well, just take tidyverse, for example. You go and install tidyverse and you're going to get ggplot2. You're going to get dplyr. You're going to get mergreadr, right? It's going to just start installing all these other packages. How R determines that is by what's in that, what's in the description file and the namespace. So it looks at that and says, oh, I don't have this package already, so I'll need to go get it. So you can't, this use package function only allows one parameter at a time, but this is something you're only going to call once as you're kind of getting your package set up. Good question.
Jason,
Yep.
I don't want to stop your flow here, but I'm curious,
go.
Do packages operate similar to a virtual environment in that when you build it, you're essentially locking in a versioning system? And I'm just wondering how you manage that effectively, but that might be later in your talk. So I just want to kind of place mark it.
Yeah. Let's bookmark that question. So some of it is manual, and it's going to somewhat depend on how you work with GitHub. So as we'll see a little bit later, and actually you probably use the install_GitHub function to install a package from GitHub versus CRAN. And so a lot of times it really becomes a GitHub management issue more than a package management. Although in the description file, you do specify the version, and when you want to increment it, you really got to do it manually. And we'll take a look at that in a little bit. All right, so the big key part, and often what is the most time consuming, and admittedly, the piece I like to do the least is documenting the code, but it is really important to do. And with the introduction of the Roxygen package, or it's now Roxygen 2, really makes documenting our objects and functions in particular much easier. Our packages really use the documentation. So if you go to what I'm talking about is like if you're in R and I do we're going to actually look at the documentation for the sum function, and I do $sum. What I'm talking about is the documentation that ends up over here. Where does this documentation come from? This is in the package. And so there's a structured format. They end up in what's called RD files, which is really sort of a LaTeX style syntax. It's kind of LaTeX-like. And editing those files, to be honest, is a royal pain and not something you really want to do. So Roxygen kind of simplifies this a lot. And it really adds two key features. One is that the documentation now is going to be right in the R file where you're defining your function. So the documentation and the code are really right next to each other. So as you make modifications to your code, you can just go to the top and sort of make the modifications in the documentation as appropriate. It also allows you to use kind of markdown style syntax instead of using LaTeX style markup. So it becomes a lot more readable. The way it works is the documentation starts, it has to be on the left margin, but you use the pound single quote, right? So the pound is a comment character. So what Roxygen looks for is like that single quote immediately after the pound next to function definitions. And so it knows that's kind of a special type of comment that it will know how to parse. So let's look at an example. So here is the most basic. So here we're looking at the sum function. And so you can see the documentation starts with a pound single quote. The first line or the first sentence is going to become the title. Roxygen is going to figure that out. So you can see sum of vector elements ends up over here as sum of vector elements. The second paragraph is going to be the description. right? So if you look at a documentation, there's always the first piece after the title is a short description. Then it gives you usage. This is all worked out automatically, so you don't need to do that. And we'll talk about arguments in a moment. Then anything after the second paragraph goes into the detail section of the documentation, right? So that's really all you need to do. So it's, and then you can see here's the beginning of the function definition. So it resides literally right next to the function definition. And so you can kind of just code it that way. Now, the parameters, what's kind of interesting is there's a whole, Roxygen has a whole bunch of tags that are, specially defined. So the first one that you're going to use a lot is the @param. So right up here at the top, we can then add @param, the name of the parameter, and then you just write a description, and that will end up over here, right? So here's the parameter name, and then here's the description. You can, there's a @return tag, and after the return, you give a description, and that would, you can't see it there, that sort of describes what this function is going to return, if anything, right? You have an @examples, and then on the subsequent lines, you can just type example R code, right? And so I love this a lot. That's typically what I do. The first thing I do when I go into documentation is I scroll right to the bottom and look at the example code. So you can put that right after that. If your documentation is getting long and you kind of want to have subsections, you can use @section and then title, and that will create subsections in your documentation. If you find you're using the same parameters over a whole bunch of functions, you could define the parameters in one function. And as long as the parameter names are the same, you could use something like inherit, or just inherit params, or inherit section. And after that, you put the name of the object or function that you're inheriting from, and all that documentation will be copied over. So that's pretty handy. There's also a see also. So you could do see also, and then right after it, put the name of some other function or object. And that puts a link in the documentation so the user can kind of navigate around. So, and then finally, export. And you just put @export if this function is meant to be public. If you don't put export, then it won't be available to the user of your package. It can only be used internally. So this is an important one that you probably have on a lot of your functions. So here, sorry if this is a little tiny. I tried to get it all to fit. So this is mostly the full documentation for the summary if you were using Roxygen. So you could see, right, title again, description. Here's the longer one. Now we could see how the parameters are set. So we have parameter, the ... parameter ends up here. Then we have the na.rm and the description shows up there. I truncated the return, but that would be there. You can see this is export, so it's public. And then we have some examples. One little bit, there are a few instances where you might have to leverage LaTeX style formatting. So this is one example where, so LaTeX for markup usually does \tag name, and then in curly braces, sort of the parameter. So if you're used to like HTML, this might not be so foreign. But essentially in this example, what this is saying is don't run the code in there, meaning don't run at the time the package is built or installed. So one of the things R does is it will run all of the examples at build time as a way of testing some of your code. So you could put test code there, although we'll look at a better way of doing testing in a moment. But if a particular piece of code is going to take a long time to run, more than a few seconds, you might want to put a don't run, but still want the user to see that example code. Okay, so data, if you have a data, data files in your package, you need to document them in a similar way. So I'm going to have a data frame called cubic df that we'll create in a moment. Really just has two values, X and Y. And in fact, I even put the code here that I used to create it. And we'll see when I walk through the demo, we'll see that. But the first line is still, the title, and then we have a description. But of course, we don't have parameters. What we have instead are our format. And that's just a description of what's in the data frame. So one area is you could use the describe. This is a LaTeX actually to do kind of enumerated lists. And then there's an at source, which is often useful, particularly if you got the data set from some other place. But otherwise, it works in the same kind of general format. You sometimes want to have, or you're probably going to want at least some basic documentation, kind of an overview of your package beyond the title and the description that's in the describe package. So you can use the use package doc. This will create a file for you to fill in. There are a few tags specific for this. One is keywords. This is nice because this will help CRAN index your package. So if people are searching for it, this is one way they could look for it. And then the ones that I generally put the package level, and I think this might go to Bikram's question. So previously we talked about, the dependencies that go in the describe file. That's really specifically used at install time. But you also need to tell R which packages are actually being used by what functions and at what time. And so you can add these at import package. So think of this as anytime you would have used the library to load a package to start using it, what you're going to do is just instead use at import and the package name. And that ends up being the equivalent. You can think of it as being equivalent to calling the library function. And we're going to put this in the Roxygen documentation, and Roxygen will take care of putting it in the proper places so R knows what to do. However, that's all well and good. You can do it that way. It's generally preferred, though, to only import the functions or objects from other packages that you need. And so you can do import from package and then list the functions or objects from that package that you're going to want to include. And it's just space separated. There's no comma. So for example, I know a lot of people know one of my favorite functions are the describe and describe by from the psych package. But there are well over 100 functions in the psych package, but I'm only going to use those two. So I do import from psych, describe, space, describe by. So I have those two available, but it's not going to bother loading the rest of the package. That's really handy to avoid name collisions, things like that. So, and it makes your package a little bit cleaner, a little bit leaner in the way it works. Okay. Okay, so this is sort of my summary slide. Like I said, you can use most markdown syntax or code highlighting, but there's a few things, \code if you want the text in the help documentation to be in sort of a fixed width font to look like code. You can just surround it with \code. There is a \link that will, so you can do that. Although I just learned you can use this syntax, which is kind of markdown. So you can put in square brackets the function name, and that will become a link to that function's documentation in R, which is kind of nice. Don't run, I think I already mentioned. And then we saw this in the data documentation. This is the other one I use where I want to have sort of a enumerated list in the when I'm describing the elements of a data frame, right? So I'll put item. So this will be the column name, and then I'll have a little short description of what that variable is. So these are the only kind of a little bit funky LaTeX style stuff you still need to kind of be aware of. All right, the next big component of an R package are vignettes. And vignettes are really just long form documents that are going to describe your package in some way or leverage your package to describe something else, right? So it's somehow related to your package. To get started, I just recommend using the use vignette. It's much easier. Way back when vignettes had to be written in LaTeX, now we can write them in R Markdown. And if you call this function, this will again set up your package so it will know to use knit_r to build your vignette, and you could do all that. So when you call this, the first thing it does is gonna create a vignettes directory. If it doesn't already exist, it will add all the necessary dependencies to the description file. And then because I called it Lois, it will actually create a file called lois.rmd file. And then from there, it's the same kind of R Markdown file that you would that you've been doing. If you took data 606 with me, you're working with R Markdown every week. same formatting structure. But now you can use your package to do some of that. So I'm not going to say much more about that. There's a link to here that has details. And if you're not familiar with R Markdown, I recommend becoming familiar. And there's on this page some information about the different kinds of formatting you can use. All right, I think this is the last bit, is testing, kind of a critical part. So you've wrote some functions, you wrote some documentation, and now you want to make sure everything works well. And you actually want to do the testing in a way that it's reproducible. So you generally want to write a test once and run it over and over. So if you make changes, you want to run all the back tests to make sure you don't break something. So there's a package called testthat that provides a really nice framework for doing testing. And again, in the use this package, you can just say, on setup, use testthat, and that will set everything up for you. What that will do is create a tests directory and then a testthat within that test directory. It will add testthat to the suggests because you'll need that to run it. And it'll create this file testthat.r that will just get triggered anytime R command check runs. So R command check is the command that checks whether or not a package can be installed kind of behind the scenes. So you're going to do this once, and that'll get everything set up to start building tests. You want to write your first test, just call use test and whatever your test name. And when we go through the example, this will probably make a little bit more sense. That'll create an R script for which you can do your testing. Then you can run it in the dev tools. There's a test function that will run all your tests. And then you just repeat lines 2 and 3 until the test succeeds. You're going to modify your code and or test, run the test. And when everything succeeds and you feel like you're pretty good, then you can go to step 5, which is repeat 1 through 4 until you have tests that cover as much of your code as you possibly can. Now okay, so again, sorry, I've got a slide before this. So this is a basic structure of a test. So we're going to really call a function called test_that. The first parameter is the name of the test or group of tests. So you can kind of group them together and kind of conceptually, however you like. And then you just have this expression, and you can put any R code in here, right? And generally you're going to leverage, test functions in your package. But there's a whole bunch of these expect_. And the way this works is the first parameter is what you're expecting, and the second parameter is what you're testing, right? So you're going to do some arithmetic in your function. Here we're just kind of doing some silly numeric comparisons, and just to kind of show how some of these things work, right? So if we're doing expect equal, right? So 10 plus some little bit of error will pass, right? So R knows there's sort of numeric accuracy, floating point accuracies that may vary from platform to platform. So there's some latitude in terms of how far numbers could vary. But if I do, then there's also expect identical. So equal is great. Like if you might suspect, you have a floating point number or a real number. But if you know for sure you're dealing with integers or something, you could do the expect identical. And this is going to be a little bit more strict. So you could see this one would pass, but these two will not pass. These will actually throw errors. And these will get run when you run check or install on your package. I stole this quote. Hadley had this in his book, but I really liked it, by Mark Fowler. And I'm kind of very guilty of this. I was doing this all day today, although I didn't know how to write a test for what I was doing. I tend to put print statements all over my code, and then when I get it to work, I delete them. And really, the more proper thing to do is actually write a formal test, because once you figure it out, you kind of want to repeat that test anytime you keep making modifications to your package, and ensure that when you make another change, it doesn't break something else. testthat has a lot of expectations that you can do or that you can use. So this is just all the ones that are available. You can see things. I'm just kind of browsing real quick, like S4 class if you're doing some object orienting, or you're expecting an S3 class, to make sure you've set up if you're doing object-oriented programming, you have less than or equal to. So there's a lot that you can look at here, that you can probably find one that you need, and you could write your own if you want. Now, I do a lot of visualizations, and this becomes a little bit trickier to test, but is equally important. So there's another package called vdiffr, which is an extension of testthat. And it's really kind of neat, because it allows you to kind of track changes in figures over time. So here we're actually going to put this lowest viz. So the package we're going to build is really designed to create a ggplot figure. And so I'm loading a data, and then I'm creating that plot, and then they have an expect doppelganger. And so this is just, I named it. This is the test name for this particular subtest of this group, and I'm giving it P, which is the output of my function. What this does is it will maintain sort of a library of images. So every time the test is called, the first time it's called, it's going to pass because it's just going to say, well, this is the reference image. Okay. And then as you start making changes, if you make changes that kind of impact the image, it will throw an error. And if it throws an error, there's this snapshot review function that will allow you to look at the two images, kind of overlap them so you can see what the differences are. So if you added you're doing a scatter plot and you somehow added some noise into the image, and it's a little bit different, you can kind of quickly see it. And then through that process, it's kind of interactive and say, oh, no, that's okay. That's a good change. So make that the new baseline image, and then tests going forward will be compared against that. So it's kind of a clever way to kind of do testing where you have figures. So I just wanted to point that out. So once you've done all this, right, now we've got all the components of our package, right? We got some functions, we got some data, we got some vignettes, and we've written some tests. So we're now going to end up in this cyclical process where we're going to build and then we're going to test. So you're going to call document, right? That's going to parse all of that documentation you have in your R functions, all that Roxygen documentation, create those RD files for you. It'll update the namespace file for you, and if necessary, make modifications to the description. Then you can call build. This will actually build your package as a binary. So it'll create a .gz file that you can then pass around. Or you can just call install, and that will install your package from the source into your working R setup. And then you can load it and use it. Then you'll want to run tests. So you can call test and then check. So test will just run the test that you've written, and then check will run those tests, and then we'll do some other things as well. Built into the system, there are what are called CRAN checks. So you can run all of the tests that are run when you submit a package to CRAN, but locally. And that's generally a good idea to make sure those all pass without issue. When you do that, things either come back as errors, warnings, or notes. In my experience, you really need to deal with everything. If errors and warnings will probably quickly get your rejection. Notes sometimes can get by if you provide an explanation as to why the note occurred and why you can't get rid of it. They will let things kind of get by, but we'll look at that in an example. So let's look at a demo. I think this is where this might be most useful. So I'm going to build off of the Shiny workshop I did in November. So we built this visualization. Really, we wrote a function called lowest viz that kind of draws a scatter plot, draws the lowest regression, and then at a particular center point, right, is going to draw that, so we're trying to estimate the lowest regression here at this point, and it's using a localized regression. So we can see here, this green line is the localized regression, and the shading of the points have to do with the weight of the regression. Not going to go into too much details about how this works, but we want to convert this into a package. So let me change. I'm going to jump over to RStudio. And I will share this R script. So hopefully you can replicate it later to kind of go through everything. I'll also post the slides and the recording and the source code for the slide deck. So of course, I'm going to load dev tools, use this, and tidyverse. I think I was using something in there. And so you could probably just leverage the script for yourself to get started. So the first thing I'm doing is defining the path. So for those who are not Mac users, the tilde is my home directory. So that's where I'm going to do it. One little note is usually I just call create a package, and this open parameter by default is true. And I like that. And what that would do is open a new RStudio session for that package. But just because, so I don't have to keep swapping screen shares, I'm setting it default. So you could see here, I ran some stuff. It says, okay, wrote this description, did all that business. And so the other thing I'm going to do that's generally not a good idea is change my working directory. And then I'm going to click this button to change my file viewer. So you can pretend now I'm in the lowest project, right? So my working directory set, and here's the file. So we can look around. So we can see my R directory is actually currently empty. We can open up the description file and we can see what we get. And a lot of times I would just start modifying that, but I'm not going to do that quite yet. We can look at the namespace, which is currently blank. And then RStudio is pretty clever. It'll say, you know, this is read only. This will be modified by Roxygen 2. So you really shouldn't do it, but we'll look at it from time to time just so you could see what's going on there. All right. So here's the list of our packages. I'm just going to use a GPL3 license. And we can see it's telling us what it's doing. So it added the license to a couple of things, right? So now we have the GPL license file in the root of our directory. If we look in the description again, we now have the license specified. Right, pretty nice.
Vikram has a question about
I'm sorry.
path.
Yeah, so if you're on Windows, it could be, you could go relative to your working directory, or it can be an absolute path. So absolutely, like C:/ blah blah blah. Now, when I was on Windows, I think you can use forward slashes. Otherwise, if you use a backslash, you got to do 2 backslashes. You got to escape it. But unless things changed, and maybe some Windows users can chime in, you can use forward slashes in lieu of backslashes. All right, so I know, so the way I got here with this list here is in my original function, I knew I had a library for ggplot, dplyr, stats, right? So these are all the packages that I had. So, you know, a lot of times the way this works is I just write my functions in R scripts and I source them. And so usually at the top of that R script, I have a bunch of library calls. And so that's kind of how I built this list. Is I said, all right, and almost everything is imports, except for, actually, I don't really need that. I'm going to take that out because that'll get added later. So the only suggestion I have is the vdiff-r, because I'm going to want to use that package to do the testing of my images. Okay, so if I run this, okay, so a couple of things. It says, okay, added it to the imports in the description. And this is kind of a really good tip, probably going forward. I'm trying to do this more. If you're using functions in the stats package, it's really recommended to start doing, you know, then doing stats : and the function name. And that just tells R that, well, in case that function is, you have the same function name in 2 different packages, this will ensure that you get the right one. But it also makes, I have found, debugging a lot easier, because that's often where an issue comes up. Okay, so now I can edit this. So you can see here, we have all our imports and suggests all taken care of. I am going to take these bits. I wrote this out ahead of time, so I didn't have to do it live. I am going to put this here and delete. But I want to show one other thing. I should have done it this way. So if I wrote this very long description like such, right? Oh, shoot, I took too much. Version needs to be on its own line. Okay, right? So I have this really long description. I can go and call this use tidy description, and look at it, kind of nicely formatted everything for me. I would also probably start to fill in, you know, author, that kind of stuff. But I'm not going to do all that for now for the sake of time. Getting back to Sean's question, right? So here's the version. I don't think there's any strict rules in terms of versioning, so you can use what you want. 4 sets of version numbers is a little nuts for me. I tend to do something like, I usually start with something less than 1 as I'm starting to work with it. So I might start at 0.9 if it's like pretty close, or maybe I'll start at 0.5, or I could do 0.1. And then like I think 2 sets of numbers is sufficient. So I have, 1 will be my first major release, and then I'll do 1.1 for, bug fixes. And then if I'm going to add a bunch of new features, I might make it 2, but that's entirely up to you. But let's just call it 0.1 for now as our version number. A couple other things I didn't mention, because I am going to put this on GitHub, I will want to create a README file. So there's, of course, a use this. We'll try to fill some stuff in. So it creates the README. If you want your README to be an R markdown, you can put an R here. That is valid. And then one that you'll need to have for CRAN is a news file. And this is, this will, you usually have a bullet, a header for each one. And if I'm going to do the next release, this is sort of where you put your release notes as you do it. So that's all a news is, kind of a release notes file. So I want to create a data set. So here I'm going to create a data frame called cubic df. That's just that I generate randomly. So I got a bunch of X and Y's. This is kind of a silly example, not typically what I would do. But again, I'm going to use another function from use this called use data. Okay. So what it's going to do here, let me hit refresh. So you can see it created a data directory, and it put the data frame into an RDA file, which is the proper format. And I think, it did not. Okay, I'm going to do that in a minute, right? Okay, so great. Now I have a data set. Now I want to create that package document file, right? And so I just ran that. And so it gave me the skeleton. So you can see here, keywords, LOES, regression, visualization, right? I can fill in some of those. This bit is for use this. I'm not entirely sure what that is, but I could add more, some more description here. I could say this package is designed to teach LOES regression, right? And notice, like when I hit R Studio is aware of Roxygen. So as I hit return, it knows I'm still in a comment block, and it'll add that properly. All right. Then I want to create a vignette. So if I call this function, created a vignettes directory, and started it up. So really the major difference between this and a regular markdown is output is going to use the HTML vignette format, which is just going to look like a regular thing. Then you have to add this little bit here. It has it here. You can just really ignore it. This vignette index entry. So if you've ever typed, so if you do vignette, I think if I just type it, it's going to open up and give me all the vignettes for my installed packages. So this is going to be the vignette name. And I think there's a description you could add that, adds this bit. So it's just what gets indexed. But from here, I can knit from here, which is fine. Okay, but I haven't done any installation, so it's currently failing. So we'll come back to that in a moment, but we have the skeleton set up. Now, I'm cheating a little bit here because I have my visualization function. I have another R script in the documentation for my data, but we'll look at that in a second. So I'm just going to copy these things over. And I'm also going to fix up my, so this is also going to copy over the completed vignette or somewhat completed vignette. And then we'll talk about this in a section. So there's a little bit of a shiny app. So let's just look at a couple of things, right? So I didn't really do anything here. Let's look at the LOES viz. So this function is essentially what I wrote in the last workshop. I did fill out the documentation, but even when I get in the habit now, even if I'm just writing something locally that's not in a package, I still use Roxygen style documentation just because I find it readable and it keeps me organized. So this is all here going through, and we can see I have a little example here, and this is nothing new, right? So it's just a function to do ggplot. So that's going to be the kind of the heart of this particular package. If I look at data, right? So I have this cubic df package that I'm going to use. So I have a title. Here's a little bit of a description, including the code of how it was created. And here's that format. And then the source just says it's randomly generated. And yep, so that's all there is in there. Oh, I already talked about that one. And then the shiny one is just a little function. This is actually the shiny app. I'm going to kind of skip over this for now because I have a couple of slides to talk about that in a second. No questions coming in. Good. Okay. What else did I do? The vignette now, so you just can see a little bit filled out. So this is all the same. I did add, because I like my output in the console, not in the document. So those kinds of things you can still do if you want. This still won't build because I haven't installed Lois yet. But you can see I just have some text. I can have some math JAX kind of formulas if I want. And I can have R chunks where I'm using my function. So this is a very brief, kind of simple vignette. The last thing I did is, if you want to have any kind of arbitrary supporting files, whatever, it doesn't matter what it is, you can create a directory called inst, I-N-S-T, and you could put anything in this. This gets copied at install time to the package directory. So if we were to go to, shoot, hold on one second. Let me see where my library. So if I do .lib paths, right? So this is where R on my computer is installing packages. So I'm going to copy this. I'm actually going to browse to it real quick so you can kind of, it's not quite doing what I want it to do. So I want to go to library frameworks, r.framework versions. Let's start there, and then I can click through versions. So I'm on ARM, resources, library. Why don't I hear this? Okay, so here are all the packages I have installed. Lois isn't here yet, but let's see if I can find a simple thing, something that I know won't be too complicated. What do we see here? Well, this is going to be super complicated. Where's ggplot? Well, grid extra. Okay, so this looks a little bit different because this is a binary of the package. So documentation's now kind of in these database kind of files. All the R functions have been compiled into a sort of a bytecode version. Tests are here, but if there was, oh, you know what? Visual stats, I think, would be a good one, right? So, which is a package I've written. Yeah, here we go. So this is what it would look like, because I have it in my source. I have int shiny, so that shiny folder just gets copied right into the root of that file. And I'll show there's a way of figuring out where this file is dynamically. And this is kind of how I start up, right? So this is just the shiny app. So that's really kind of a convenient way to kind of, that's often where I put shiny apps. But you can put literally anything in there. And if you get to a place where you need to start writing, code in another language, like if you're using RCPP, and you're going to write some pieces of code in C or C++, that would often end up in there. Okay. So far, so good. Next, let's set up a test. So here we're going to configure it. We're going to use testthat, and let's create our initial test, right? And so by default, it just gives us a simple one like multiplication. But this is the one from the slide deck. So let me copy that so we can put that in here, right? So this is the same one here. I'm going to load the cubic data frame from the package. I'm going to call Lois Vig, and I'm just saying expect doppelganger with that p-value. So now I have one test. All right. So first step, document, right? And so we'll run that. So it did a whole bunch of stuff. So what did it do? It created a directory called man, right? And so here I want to show you this, right? So this is how we used to have to write documentation in R, right? In this kind of LaTeX style format where you had all these pieces, but now this is all just kind of managed for you automatically from Roxygen. So you're never going to edit these files directly. That document file is going to take care of that for you. Next we can do is we can build. So this is going to go through the process of building the file. Right. And so it created a Lois tar.gz file. And so if I go up one directory, there it is. So that's binary version of this package, ready to share. But I don't often do this. I mean, when I need to share it, I do it. This is kind of what I'm going to do is I'm going to call the install function. Now build vignettes, I think defaults. And sometimes I like it faults, especially if I have vignettes that take a long time to run and I'm just testing functions. It's like, I don't need to build the vignettes every time. So you can kind of modify that. All right. So you can see it went through and it's installed. So now if I go down, I'm going to skip down a little bit, right? Now I can call it, right? And I can look to see. So here are all the exported objects. Oh, so this is what a couple of other things I should have mentioned on this document. So if we looked at like the Lois Viz, for example, right? So I have at export, right? So that's important. And then in here, oh no, where did I put it? Where's my, okay, put it right here. So in this case, I put it with my function. So I needed ggplot and dplyr for this function to work, right? So I have them there. When I called that document function, it updated the namespace file. So you're basically going to have import and exports. Exports are objects in this package that should be made public. And then import are other packet. Well, the import are just importing other packages completely. And then import from is like, so from the Shiny BS package, I just need the BS popover, right? From the stats I have, well, I got a bunch of functions, right? These are all from the stats. So I'm going to import those to kind of use with my package, those functions. Okay. I forgot to mention that. All right. Next thing I might want to do is do my test. Of course, it's going to pass this time. Great. Tells me I got one fail. I got one warning. And the warning is just telling me, well, I just took your first snapshot, right? So if I rerun test, now I'll get a pass, right? Because the snapshot has been taken. So on the first tick, it's going to do that. So snapshot review, there's no snapshots to review here because everything worked. Now check is going to do a little bit more. And you'll see as I run it here, it's going to run those tests, but it's also going to build the vignettes. It's going to run all the example code in the documentation that you have and run some other CRAN checks to make sure it can be installed and all the rules of packages are kind of being followed. This is kind of small, so it shouldn't take too long. All right, great. 0 errors, warnings, and notes. So now I can load it. I can see I can see I can load a data frame. I can call the Lois Viz, just the default. I get my function here. I'm using the cubic in this example. All right, and then I can run a Shiny app. I'll talk about that in just a second, or I can look at the vignette. So here's that vignette now built as an HTML file and available in the package. All right, so let me go back to the slide deck. Questions about that? Or actually, before I do that, anything people want to see in here? I know this is a lot, but my hope is that as I'll put the script up, you can run it and kind of play around with it and kind of poke around the package to see what different things happened. All right, I develop a lot of Shiny apps in particular for teaching. And so I often like to distribute them in packages. And so there's a couple of approaches you can do this. As I mentioned, one is just put it in the inst directory, and that's great. And then you can write a simple little wrapper function. So here I just called it my Shiny app. You can call it whatever you want. And this is the key piece right here that you need to know is the system file. So I'm looking for the Shiny directory in the lowest package, right? That's kind of optional. So I think I have another, where's my RStudio, right? So if I do this, well, it's empty because I don't have anything here, but I could say, oops, ggplot2. Let me get rid of this piece because it probably isn't a Shiny, right? So the system.file with the package parameter is just going to tell me where it is. So then I could do something like list.files if you want to see what's in there, right? So anyways, that's kind of a handy way. And so if you put it in a Shiny folder in the inst directory, well, you can just do this, and I'm just calling the Shiny run app. That's all there is to it. That's kind of the simplest way to do it. Now, if you want to get a little bit more complicated and you want to pass parameters to your Shiny app, you can actually put the server and UI functions as just functions in your package in the R folder. And so what's kind of nice about that, so here's an example where I might want to pass a data frame called the data, for lack of creativity, to the Shiny app. And so, and if you don't specify a data parameter, then I'm gonna just give you old faithful data set. And so that's on the Shiny server side. And so this little app, all it does is prints the output of a table. Okay. So in my encapsulating function that's going to call it, you can kind of use this, and I'm working on a package that hopefully makes this a little bit more generic, so you don't have, this will be reusable, right? I just have my run Shiny app, which is passing in a data, and without going into too much details, it's going to just insert that into the environment if you specify it, and then start up the Shiny app and run it. So, here I could run it and say, give it empty cars instead of the old faithful or whatever data set you want. So I have a blog post I wrote a little while ago that it goes into this in much more detail. But those are a couple of options for you. All right, so now you've got this package, you've built it, you're using it locally, everything works great. You want to release it to the world. GitHub's probably the easiest way to initially publish it. And so you can initialize a Git repo in your directory with use Git. And then once you have a Git repo locally, you can just call use GitHub. And then once you do that, you can share it with everyone and say, okay, just install it from GitHub. And it's going to be whatever your GitHub username and the repo name. So why don't we do that? And you'll see actually really kind of how easy this is. Actually, we're going to go down here. So I'm going to say use Git. It's asking me, okay, yep, it's okay to commit all that. Great, did my first commit. So now I'm going to say use GitHub. I've already configured my RStudio. If it wasn't configured, it would kind of walk me through that process. So, yep, absolutely. And then if I do new share, it opened up in the browser, and here it is. It actually created the repo for me, put all the files as they were in my directory up here. And so here's here's your package kind of published on GitHub right away. If you want to go to CRAN, all right, it's going to take a little bit more process. There's a function called release in DevTools that is going to do a little bit more checking, I think, than sort of just the base check. It's going to go really deep. It's going to take longer to run. So a couple of things, if you want to go down that path, you should really read the CRAN repository policy, make sure you're following all the rules, and you're going to have to confirm that you read and that you agree to it. You'll create a file in the root of your package called CRAN-comments. And it's just a text file that you can put any messages, because the release, it's kind of interactive. It'll ask you questions as it's going through, verifying different components of it. and it'll actually zip it up and submit it to CRAN for you. And it will pull the, the text from the CRAN comments. And so there's a place to add notes so that the CRAN reviewers will see that when they review your app. Some of the tests are automated, but there is quite a bit of human interaction in that process. Usually takes a couple of days or so for something to get released. I will say this: if you're going to go down this path, don't get discouraged if your package doesn't get approved on the first attempt. Rarely does, even for me. Hadley, in the end of his Our Packages book, has quite a description. He even got banned from CRAN for 2 weeks. Considering how prolific he is, it's to me kind of incredible. I don't know the story of that, but you will sometimes get pretty terse messages back from them, and that's only because they are super busy. As I mentioned at the beginning, we're closing in on 19,000 packages, and they're volunteers. So don't take it personally. Don't get discouraged. They are often very helpful, and they'll say, "Oh, you need to fix this in your package," and then you can go fix it and then resubmit. And you put that in your comments and say, "Hey, this is a resubmission. I'm addressing this issue. Should be okay now." Now there are in the book, if you're going down this route, there's probably a little bit more due diligence that you should do. Because what CRAN will do, one of the things that gets me hung up is, I'll often test on my Mac, and I'll test on Windows, but CRAN will test your package on all different flavors of Unix, Linux, Mac, and Windows. And so sometimes things can go wrong on other platforms that you don't anticipate. Technically you're supposed to test it on everything, but they still test on Solaris. I don't have access to a Solaris machine. So if something goes wrong there, I have to wait to see what the log files are and try to fix it. All right. Then you want to start to publish it. So another thing I really recommend, there's a package called Package Down, really slick. So why don't we just do it? So if we go back over to RStudio, so I can load the package down. I'm going to use this to tell, that's going to do some configurations to say, well, I'm going to use Package Down, and then I'm going to build it. This should just take a moment. First thing it's going to do is, you could see it created a folder called Docs. That's where it's going to build the website. All right. So it opened a browser for me. So hold on one second. Let me just see if there's anything else here. Will this republish? Yes, I think this will just publish. Oh, no. Oh, okay. So that is only a first time. I was wondering about that. All right. So if I go back to my browser, it opened up in the browser. So the reason why I'd want you put it in the docs folder, right? So you could see here, so this is the README page, references, so I can browse through all the documentation, kind of a nice web format, and getting started, since there's only one vignette, shows my vignette, all kind of a nice format. So if you publish it, if I push the GitHub as a docs directory, I can go into GitHub, into the Pages tab, and say, well, I want to use the master, and I can say I want to use the docs. And what that will do is, now our GitHub will host your website for you. And so if I pushed it, this link would work. But I'm not going to do that at the moment. So anyway, so now you quickly have a website to kind of publicize your package. All right, wrapping up. So here are a whole bunch of resources. So the sort of the Bible at this point, as far as I'm concerned, is Hadley's book on called Our Packages. Goes into great detail. I think it's pretty well written. I sort of followed largely his structure a little bit. I jump around. My path is a little bit different than his. But anyways, a lot of detail. If you're new to GitHub, I think Jenny Bryan's book here is really great if you want to publish it. And then these are all the documentation pages for the different packages. I'll just show real quick, because I think like Roxygen is really nice. There are a lot of references, articles. So you can extend it. Trying to remember where it is, but there's a page on this website somewhere that lists out all the tags that you might need. And then this is the important but less, I think using Hadley's book, but this is the official R core groups documentation on writing packages. So there's some details in here. And then I think somewhere on this page is also documentation for the CRAN policies and rules. There, of course, there's a cheat sheet from our studio on DevTools. You can download this, print it, gives you really the key functionality and different components. I think we went through it. So you have code, test, vignettes, documentation, data, and kind of how all these things kind of interact. So I hope this was useful. Happy to stay on and answer questions. Kind of a very quick and crash course on R packages. Don't be afraid of them. I think the first one is going to be tricky. The second one will be a little less tricky. And then a lot of times I even try to organize analysis projects kind of as packages, just so at some point it'd be easier to kind of distribute them and kind of pass them along. So thanks for attending.
Yeah.
Answer questions.
Will this recording be shared somewhere?
Yeah, I'll post it probably tomorrow. I'll put it on the 606 website. And then there is, I did have a link earlier. There is an R meetup group page that I created in Blogdown. So I'll post it there. I'll post it around different places. I'll post it on Twitter. So yeah. And I'll post not only the slide deck, but I'll post that R script that I used to kind of walk through the demo and the source files that I copied in. So you can replicate everything I did. I was just trying to give a tour. I think as you're going through, I always found it useful. This is sort of my tip is you can go to my, if you go to my GitHub and look at my repos. So the one I'm kind of working on now a lot is this Shiny demo I was working on today and this visual stats. So you can see this is an R package. So for me, a lot of times I just want to look at an example. And now I just look at, old packages I've written or ones that I've already done that are kind of complete. And you can kind of get a sense of what's going on. So you can see got a couple of vignettes in this one. You can see I like that int Shiny. In this case, I have folders within that because I have multiple Shiny apps. But anyways, that's what I do a lot. So here's a case where I have the docs directory. And actually, I think I have a link here. So if I do open a new tab, right? So here's kind of my package down website. And we can look at, here are the different articles, that I'm collaborating with someone else on. And then if you want, I even have the script to create the little hex sticker. You can kind of see how I do that too. All right, well, I'll stick around for a few minutes. I'm going to end the recording now, but thanks for coming. Have a great night. If anybody here has an idea to give a talk or an idea of a talk they would like to hear, I'm always trying to find other people to do talks for the Albany R group or within just the MSDS program at CUNY. Either one of those would be, great to have other points of view. If it's shorter, we could do that. So Ashok is asking, when's the next meeting? I don't know yet. Do you want to propose a topic or time? Maybe we can start doing some of these in person. That would be great too. Oh, you would? Can you send me an email? And then maybe we can schedule something.
Will do, for sure. Thank you so much.
Yeah, thank you.
I'm from Calgary, Alberta, by the way, so I won't be able to do it in person. I'll do it virtually if that's
no worries.
all right.
Yeah,
But I have some interesting R Shiny project that I would like to showcase.
Yeah. Let's email me and let's set something up. Maybe in early April.
Yes, sounds good. Thank you very much.
Yeah, cool. Yes, on debugging. Sure. Yeah. I don't know if I'm the best person here, because I'll give you a sense. This is a problem I'm working on. Is this the right RStudio? So you can kind of see I'm in the middle. I'm working on the Shiny demo. So here's my sense of debugging. I actually just have print statements, and I always put them on the left margin so I see them, so I remember to delete them before I publish. But this is debugging within a Shiny app, and so I don't. There are tools, and there's a whole chapter I think in the Shiny book on debugging, but this is kind of what I do. I also often create dummy input objects, because the input, if you're doing Shiny, right, often like, so I need a data frame. So what I'll often do is I'll do something like, I'll create a block I'll call if false. I do this because if I source this file, like I often use this source on save, then whatever's in this block won't get run. And so my way of debugging Shiny apps a lot of times is I'll say input, input will be a list. And then I'll say input, what do I need? Data frame. And I could say, well, this is going to be a string. So I could say empty cars, I think. Nope. Yeah, that's right. Oops, that's not going to work because I have to initialize the list. I can do that. So now I can run kind of interactively, right? So I can say, well, does that exist? Oh yeah, so I can do that. Now I have a df, and right. So that's kind of a crude way I do debugging in Shiny. Not recommended. There are probably better ways, but it works. Oh, I realized I just sent that link only to Angela. So let me do that. Here's the Womany website. All right, gonna end the recording.